This is number 7 from the review. The first thing we want to do for this problem is factor. We have a top-heavy fraction, so we know we're going to have an oblique asymptote if we don't have anything that cancels. So when we factor this, x squared minus 16 factors to x plus 4, x minus 4. Just an easy little difference of squares over x minus 2. So we don't have anything that cancels. What we know from this is that we have zeros or x-intercepts at -4 and 4. Again, it's a -4 and 4, and that comes from our numerator. So our x-intercepts come from our numerator. And we know that we have a vertical asymptote at x equals -2, and that comes from our denominator, of course. I'm sorry, x equals +2. Since it's x minus 2, we set that equal to 0 and solve. So we have a vertical asymptote at x equals 2. The next thing we want to look for is our oblique asymptote. Again, we have an oblique asymptote since we have a top-heavy fraction. We have x squared over x. To find our oblique asymptote, we're going to synthetically divide. And what we're going to divide is we're going to divide the numerator by the 0 of the denominator. So we have the 0 of the denominator is 2, and our numerator is 1x squared plus 0x minus 16. Now remember, the remainder doesn't matter here, so this we don't care about. That's not an x, it's just we don't care. Bring down our 1. 2 times 1 is 2. So that gives us y equals x plus 2. At this point, I would graph it in my calculator. To double check all the values that I found so far, I would put in 2 equations. I would put in your original equation as y1, and I would put in your oblique asymptote as y2 and make sure they fit together nicely. You know what they should look like. You want to make sure they fit together. From this graph, you can get your y-intercept. When you graph it, you should see that the y-intercept is 0, 8. And I would use the table function so that you can get a really, really nice graph. Again, you want to plot every point that you can that's going to fit on that coordinate plane for the test. For this, I have several points plotted. I think I have 4 points for each curve. And you can check out my key as well for that graph. The last thing we need are the domain and range. For this problem, the only thing that we need to exclude from our domain is that vertical asymptote at +2. And you're going to be writing domain in interval notation. So domain for this was -∞ to 2 and 2 to infinity. And range, for this one, since the curves are on the outside of your asymptotes, the range is -∞ to infinity. If the curves were on the inside of your asymptotes, you would need to find maximums and minimums like you did on number 6. You had to find a maximum there for that bottom curve. So just be aware of that and make sure you know how to find maximums and minimums using your calculator. If you don't, make sure you ask that question before the test.
made with Doodlecast Pro.